Lecture 4.3 introduces the idea of variance and standard deviation. This is our first rather complicated calculation, and so it's critical that you work with the Revel supplements as you try to understand this material before you start to do the homework assignments. Remember that the Revel assignments are meant to be supplementary and to help you to practice the skills that you'll need to be successful with the class assessments. So the idea of variance and standard deviation is that it allows us to quantify the overall spread of scores around a mean, which is our idea of variance. Visually, this variance is the width of a bell curve, so we talked about this before. But it also allows us to talk about the typical deviation of scores from the average value. And this is standard deviation. So the calculations themselves are detailed in section 4.3. I'm not going to go over in great detail in lecture how to make the calculations. Instead, I'm going to focus on the idea of the need for a sum of squared deviations with the calculations, and then kind of send you to section 4.3 to help you visualize and to work with these numbers to create the scores that you need. So here I have a distribution of x. I can see that I have 1, 2, 3, 4, 5, 6 scores of x. And so this variable x could be anything. The point is that I have a value of 9, I have a value of 8, I have a value of 6, 4, 2, and 1. Okay? Now, I want to arrive at a deviation score. So if I sum all of these values, if I take the sum of the x's and divide by n, when n is the total number of scores, I get 9 plus 8 plus 6 plus 4 plus 2 plus 1. That's what I put here. Okay. And then I have 1, 2, 3, 4, 5, 6. That's what I put here. Okay. And then once I work through that math, I get the average score of 5. Then I create a deviation column where I take x minus the mean of x. For every x value, I subtract this mean of 5. So 9 minus 5 is 4, 8 minus 5 is 3, 6 minus 5 is 1, etc. Then I move to the negative column. I have 4 minus 5 is negative 1, 2 minus 5 is negative 3, etc. If I sum all of these up, okay, add all these up, I arrive at 0. I need to avoid that. So what I do is I square each column. So 4 squared is 16, 3 squared is 9, etc. Remember that a negative times itself is always a positive, so negative 1 times negative 1 is going to equal 1. To arrive at a squared deviations, okay, I just simply square these values. So this is my column of squared deviations. But what I want is a sum of squared deviations. And so that is expressed here. This tells me to add up my squared deviations. Okay, so each one of these, if you ignore this sigma for a while, each one of these is a squared deviations. All that this term says is add together. So I'm adding 16 to 9 to 1 to 1 to 9 to 16, and I'm arriving at a sum of the squared deviations of 52. Now, if I take the standard deviation of this, standard deviation is the square root of the variance. Together with the sample mean, standard deviation is very informative. So for example, if I have a distribution with a mean of 5.2, that's great. It tells me on average, my average score is 5.2, but along with standard deviation of 0.43, it tells me that my scores underneath the curve deviate from that value by units of 0.43. So this is in the units of x. So standard deviation is very helpful if we want to know not just the mean value, but how much scores vary on average from that mean. So looking at this in the context of the bell curve, I know that the average in this distribution is 80, but the existence of this curve indicates to me that scores vary from that mean. And I can see in terms of broad strokes that we vary from our highest score is around 95 and our lowest score is around 65. So that's very useful, but I can tell across this axis that I have one standard deviation above the mean, 2 standard deviations above the mean, 1 standard deviation below the mean, 2 standard deviations below the mean, etc. And that corresponds with specific levels. So in this case, I have an average of 80, and S, or the standard deviation of this sample, is actually 5. Okay? I know that because 1 standard deviation above the mean is 85. 85 minus 80 is 5. Therefore, standard deviation in this case is 5. 1 standard deviation above the mean is 85. 2 standard deviations above the mean is 90. 3 standard deviations above the mean is 95. Likewise, if I take away 5 from the mean, I can arrive at standard deviations below the mean. This is very helpful when we want to know, for example, what the value of x is, 1 standard deviation above the mean or 1 standard deviation below the mean. So measures of variance and standard deviation are very, very helpful. Remember, you need to go back to the book in order to work with the calculations. I don't address that here, but the textbook is very helpful in terms of giving you practice working with these numbers before you do the homework. Now, the coefficient of variation is when we want to compare variability for 2 different outcomes. So say, for example, I want to know the variance in hourly wages, and I also want to know the variance in the hours worked. In order to do that, because those refer to different metrics, wages is not the same as hours, I need to compute a coefficient of variation. And that's a fairly easy process, but you need to go to section 4.7 in the textbook to help you learn how to compute that. There are some very nice worked examples there that will give you practice with this.